Previously, we saw text-to-video generation, and then we used an image with the audio to generate a video. The same workflow has been organized now. So let's begin with multiple images that can be used to guide the video generation process. There are two methods to do that. One is in front of us, where we can use the image with a prompt to guide the video generation process. And the second method is this, where we can inject the images as frames, which should generate the video based on the given image. The red-colored nodes need your attention, as shown in the previous video. Here, you need to select the model. I tried this FP8 input scale version 3 model. The model was released a couple of days ago, but it did not perform well. The Q4 GGUF produced a better result. The mathematical logic used for the input scale makes more sense, and it worked very well in the first and last frame workflows. Right now, I will continue with the Q4 GGUF model, because this video is for systems with 8 and 12 GB GPUs. You can use whichever suits best on your system. Links to download the model are given around the node. The model goes towards the sampler with a LoRa node. You can use the distilled LoRa if you are using the dev version of the diffusion model. And this is for a system with low memory. This should let the GGUF work on a smaller GPU if your system has a 32 GB memory. These are the LTX NAG nodes, currently not producing good results. I am still looking for the best setting, and then I will update the workflow. The model is connected in both stages of video generation, as we saw in the default workflow. Similarly, we have the text encoder with the Gemma model. Connect this node if you want to use the GGUF file of this Gemma model. But you should try the FP4 SafeTensor file because comfyUI will manage with the system RAM. The prompt node is connected with some unwanted nodes. I'm using this to keep the negative prompt empty. I will break the connection when I want the negative prompt. This is for the positive prompt, and the prompt here is about a cartoon character that says "AA ... like a newborn baby," and then starts eating with a spoon. So that's the positive and negative prompts that go to the first stage of processing, and the result generated in the first stage will be decoded and made visible here. This section here, this is about multiple images, which will be injected into the empty latent frames. The first image is of a cartoon character, and I'm sure you have seen this somewhere. The image resolution here makes no sense, but it works because this will resize the image to the nearest size. Let me disable the process nodes to stop the video generation. Now, if I run the workflow, we get the image. The height is locked at 720 pixels, and the width is locked at 1280 pixels. So the image will always remain within this number by maintaining the aspect ratio. But you can keep it 1024 pixels in both the input fields, and the image will be resized with the same aspect ratio. I will keep this node in red color because you can control the image sizes from this node. The two nodes below will follow the same size from above. In the second image, the character is eating using a spoon, and in the third image, a hand appears that touches the character. The three images from here goes to this LTX image to video, KJAME node. But to make this node work, you will need the latent frames. Latent frames are the blank canvas on which the video will be generated. So with the help of the first image, after the resize node, there is again a node used to manipulate the image size. Currently, this should output the image, which will be 50% of the size of the given image. Then we take the same image size and create an empty latent video. This also takes the length of the video, which is the number of frames. The resolution of the empty latent video is half the size of this image, and the reason for making it half is that it works on a system with smaller memory. Once the empty latent is ready, the three images uploaded will be injected. You can increase the number of images, but then the results produced are bad. There is a different approach I saw on Civet AI, but it is still in progress. So the three images used in the latent video will affect the output based on their strength and their position. The position is given by the frame number, which can be any frame within the total of 441 frames in this example. The first image will be at 0. The second image will be somewhere in the center. To keep it in the center, the total frames is divided by 2. The output is 121, and the same value goes here. The third image will be at the end of the video, which will be the 441 frame. You can also push it forward, like at 416, and then decrease the strength to complete the motion smoothly. This manipulated video latent with the audio latent goes towards the process node to become a video. I will activate these nodes, and the sampler will then start processing. Also note that I got an out-of-memory error with this workflow. I tried again, and then it worked. I am using the GGUF models, so I think the latest comfyUI update is responsible for this. The time taken to generate was 124 seconds, and this is the result. The output from the sampler is further processed in the second stage. But there are two outputs from this node. The first output is for further refinement, and then the second, which is the denoised output, is for analysis and to preview the progress. However, after processing again with any of these, the final result looks identical to me. I will activate this process node in the second stage, which should add details and upscale the video to a higher resolution. This result you see here looks fine, but this was generated using the FP8 input scale model, which we saw earlier. The second stage processing took 178 seconds, and there are some extra elements appearing. This also happened when I was using the FP8 model. I will be trying by changing a few values like the sampler, or I should use the negative prompt. This get original audio node was explained in the previous video to get the same audio file uploaded. Below is the audio and video VAE with the download link. And then below, there is the audio node group. I am using the vocals only, or else the mouth of the character may not open. I had explained this in the previous video. If you do not have the audio file to upload, remove this connection from the audio latent and connect the empty latent audio. Then the LTX model should generate some audio by itself. So that was the frame injection method, and the other is the guidance method. This node is similar, but it also takes the positive and negative prompts for guidance, with the frame number and the image strength to influence the video. There are two stages where the video is processed, and the second stage is disabled. Once I get a decent result here, I will process the same in the second stage. You can get better results here, but a few times I got bad frames at the end of the video. So I had to trim the last 10 frames from the end of the result generated. The bad frames are not happening now, maybe because I updated the KJ nodes. There are many things to try, like trying different models using negative prompts and different samplers. Updates are being made every 2 to 3 days in comfyUI and KJ nodes. It is better not to rush. Looks like the negative prompt worked, but it did not have any effect when I was using the LTX NAG nodes. I will have to try a few more videos. This is the first and last frame workflow. It is similar to what we saw just now. The GGUF and FP8 diffusion models are here. Then the clip loaders. The prompt here is guys walking towards the camera and looking into the camera. And then 2 images instead of 3. These are the start and end frames. The process is similar. This 0.25 will be the 25% of the resized image used to create the empty latent video. The size is too small and not recommended, but it gives me a result within 100 seconds. Once I get decent results, then I will increase the size somewhere around 0.50 and also go with the two-step generation process. Right now, in this 10-second example, the second frame is added at the end of the video, but you can keep it somewhere between the 241 frames. So the second frame remains in motion in the last few seconds. I will run the first step, and the time taken was just above 100 seconds. And we can see if it is good or not. Then I can probably change the prompt, use a different model, or change the NAG node values. The latent size was small. Increase it to 50% of the uploaded image, and run the workflow to get a high-resolution result from the first step of the workflow. So I have added 2 more images with the prompt. I will connect both the images and the prompt. The video length is the same, only the latent size has been increased from 0.25 to 0.50. Time taken was 190 seconds instead of 106 seconds. And this is the result. The prompt was about the piece of cloth floating. Turn it into a jellyfish. Processing it in the second stage will give you a higher resolution result with more details. Time taken for the 3-step process is 193 seconds. And the result looks good. I have added this image of a girl, and the prompt is about making the image come alive with motion and animation. This is one standard prompt I use most of the time, and it works. Time taken was 112 seconds, and the result looks fine. I added a few more images and made the connection. 173 seconds, and this is the result. Do note that I am using the smaller Q4 GGUF model with the GGUF file in the clip loader, so this is a low memory setup. I will keep these prompts with the workflow, and we'll share the images so you can begin if you have any confusion. I tried a product image. The first image has some petals, and in the second image, there is a lipstick. The result looks good after the second stage of processing. That should be enough examples. The prompts are here, and the image used will be in the description. Place the images in this input folder, which is inside the comfyUI, then load the workflow, and the images kept in the input folder should be picked up by comfyUI. All the image we upload is kept here by comfyUI, so it should work because the workflow has the image names in the load image node. So that was it in this video. I will update the workflow if anything interesting comes in the multi-frame workflow. I hope the video was informative, and I wish you an excellent day.